So the first step is to pick those four, specify those four values. Let's just do A first, worry about B second. So what are we going to choose as time equals 0 for part A? Yeah, right. At the start, the instant that that acceleration starts. And what's going to be T final? It's going to be 2 seconds. Yeah, that's as good a way to, if we know the value, you might as well put that in. But that's going to be the instant that he reaches a velocity of 5 meters per second. And what are we going to choose as a 0 position? There's only two reasonable choices, I'd say. Yeah, right, either where he starts or where he ends. Let's choose where he starts, and then so p equals 0 at his location when time is equal to 0. And then the positive direction, if there aren't any other reasons to pick something else, just choose the direction of the motion, might as well. Okay, do we know the initial position? Yep. And actually, anytime you choose your 0 position to be the location when time is equal to 0, what you've done is define pi to be 0. Do we know p final? We know t final, but p final we don't know. And for part A, we don't care about that yet. That's what we're going to be looking for part B. I'm just going to leave it off. Do we know v initial? 0. He's at rest, so that means 0. Do we know v final? Okay, that's right. This is one where you have to pause for a second. We're given a speed, not a velocity. So whenever you're given a speed, you need to think about the direction. As a velocity, is this going to be -5 or +5? And how do you know? It's going to be positive because positive is the direction of motion. We chose that to be the case, and so that velocity is going to be positive. Do we know the acceleration? No, that's what we're trying to find. And do we know t final? Yes. 2 seconds. So is there an equation that works with those? Yeah, the first one should work. So 5 meters per second. I'll write this on the next page. Five meters per second is equal to 0 plus a times 2 seconds. So divide both sides by 2 seconds. 5 meters per second divided by 2 seconds is equal to a. And 5 divided by 2, that's 2.5 meters per second squared. The bottom one?
No.
The middle one?
A equals,
Oh, I see, yeah. Right. So actually, these two equations, this definition of acceleration, you can think of as, in another form, it's v final minus v initial divided by t final minus 0 using the values we have. That's just a rearrangement of this equation. It's the exact same equation, just jumbled around a little. So if you do this on a test, that's fine. I wouldn't take off any points for that. But I would recommend using this equation so you're just always approaching it the same way. You just always know you're dealing with those 3 equations, you know. So just keep in mind that these are the same. Anytime you can use this, you might just as well use this one instead. And now for part B, is there any reason to change any of those specified values? Time equals 0, time final, direction, position equals 0. No, the only reason we would have to change anything is if we were looking for something happening at a different instant. Like that could happen if part A of a question was asking you something about what happens at the highest point of a flight of a projectile, and part B was asking you for something when the thing hit the ground. Then you'd have to choose your T final to first be the highest when it's at the highest point, and then to be when it reaches the ground. But in this one, we're looking for the position at our T final from part A. So we're just going to leave everything the same. Okay, and if you have the same 4 specified values, then you know all the stuff you knew before, you know again, right? Because none of those have changed meanings. So we still know pi equals 0, vi equals 0, Vf is 5 meters per second. Tf is 2.5 seconds. And we know one more thing. We know the acceleration now. We solved for the acceleration. Sorry, yeah. 2 seconds. So the acceleration is 2.5 meters per second squared. And now we're trying to find PF. Is there an equation that works with those? Yeah, I think the second one should work. So P final is equal to 0 plus 0 plus 1/2. I'm just going to write it all out in that sort of detailed notation. So 1/2 times A, 2.5 meters over seconds times seconds, times TF squared. The seconds all cancel, and you end up with PF equal to 5 meters, right? Okay, so what's the displacement? Displacement, remember, is PF minus P initial. So that's 5 meters minus 0, and so you get 5 meters again. And so one thing that sometimes simplifies things is anytime you choose your 0 position to be the object's location when time is equal to 0, that always means that your P initial is equal to 0, okay? And if your P initial is equal to 0, the displacement is always going to be equal to your time, to your final position. So if you have questions dealing with displacement, a lot of times people will make that choice of the position equal to 0. So, equal to the location when time is equal to 0, so that you can just calculate P final, and that is the displacement.
So you don't need us to put the displacement equation on there then?
No, you wouldn't have to if you recognize that. Yeah. Question?
So if you're not here, so what if you travel 5 years around?
Yeah. Okay, so that is right. So when we're talking about one-dimensional motion, we're not talking about straight line distances or anything like that. We'll talk about that when we do two-dimensional motion. But if you have a one-dimensional motion that's that would take really good traction on your car or whatever, but if you say you start here and go this way back to here, and you're asked for the displacement, your answer isn't going to be 2 inches. Your answer is going to be the whole distance, or this whole position of this in this one-dimensional definition minus the position here. You'll get some big value. And it's the same thing with circular motion. So if it's more than 5 meters around the whole thing, he'd actually, pass the point he started and then be on to his second path. But in one-dimensional calculations, you don't care about that. You're just calculating in a way like the total distance traveled along that path, although it's not a distance, but you're just calculating the position along that one-dimensional path, which could be 5,000 meters minus the position initially.
One-dimensional calculations, they wouldn't be different for displacement?
Yes, displacements can still be negative. So displacements still have a direction. So we can, talking about displacements and positions, we can still differentiate between whether he's going clockwise or counterclockwise.
So technically the measurement would be the same distance and displacement, and you just change the direction. Displacement, you would say it's negative.
The one thing that would be different is if he was changing directions, okay? So as long as he keeps going the same direction the whole time, distance and displacement have the same magnitude, just possibly different signs. But if he goes this way for a while and then goes back the other way and then back the other way, he could have a displacement that was equal to 0 or something, but his distance would always be positive. It's sort of like you guys are sort of on the right track to think that it seems a little odd that he could have, say that this had a circumference of exactly 5 meters. He could end up exactly back at the same point and have a displacement of 5 meters. That seems a little odd, and it just comes about because of the way we define one-dimensional motion. When we talk about two-dimensional motion, we'll see that's not the case anymore. But for now, you just have to, that's just how it is in one-dimensional motion. So get over it.
I have a question.
Yeah.
If we're just going to do in-lab practice problems
Yeah.
and test prep, can we stay in this room?
Yes. You like it better in this room?
Keep it on there.
Oh, keep it on there. Why don't I just bring this in and I'll put it up on the overhead? Just because the tables, people can talk to each other a lot more easily, at the lab tables. Any other questions? Okay. Yeah.
When we're calculating distance, does that mean we take the displacement formula and throw in some absolute value brackets on it? Or?
So I talked about it just in passing when I was first defining displacement and distance. The way you would do it is break it up into legs of the journey. where you're going in the same direction. Does that sort of ring a bell? You'd break it up into all the paths where you're going the same direction, and then put absolute values on the displacement for each leg. But I don't think there's any of that on the practice problems, and if there's not, then there's not going to be any on the test.
Are you gonna record that?
Record it? That's a good question. I wasn't planning to, but I could probably do that.
If you're gonna record it, then I'll stay for a little bit, then I gotta go.
Oh yeah.
You didn't have lab in front of you. Sorry.
That's right. I didn't. Yeah, well, I'll, you know, a lot of it's going to be people working together, but I'll record any questions I'm answering. That's a good idea.